Whoa, 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 whoa. Okay, there we go. Anyways, here is solving equations. So let's go. We'll see. No comment. Yeah, I probably enjoy identities better than solving equations, but I feel like solving equations is kind of like a general algebra thing to do, but we'll do it. All right, so I'm going to solve for cosine. I'm going to solve for cosine by multiplying by the reciprocal. So when I multiply by the reciprocal here, I get cosine 3x is equal to rad 3 over 2. And this may sound weird, but we want to find cosine of something, of something is equal to rad 3 over 2. That's when that something, the thing on the inside, is equal to, let's see, positive rad 3 over 2, unit circle, let's see, pi over 6 plus 2 pi k. And it's going to be also in the fourth quadrant. Cosine's positive in the fourth quadrant. So my pi over 6 in the fourth quadrant would be 3x is equal to 11 pi over 6 plus 2 pi k. Solving for x, I'll get x is equal to pi over 18. Again, we're going to divide both sides by 3. And 2 pi over 3 times k. X is equal to 11 pi over 18 plus 2 pi over 3 times k. Not bad. I'm going to double check my work here. Yep, looks good. On to number 2. Let's see, 2. This is the square root of 3 times tangent 3 theta plus 1 is equal to 0. This is real similar to the last one. I want to get tangent by itself. So I'm going to subtract 1, and then I'll divide by 3, and I get tangent 3 theta is equal to negative 1 over rad 3. This is a value on the unit circle, and I know we kind of really focus on sine and cosine. So I can rewrite this to maybe help me look like what sine and cosine value will be. This is equivalent. This is the equivalent expression. It's just imagine reducing by half, you'd get back to here. But this is an equivalent expression. And so what I'm really asking is where is sine 1/2 and cosine rad 3 over 2? And that's a pi over 6 value, but not unfortunately, is a negative value. So tangent is going to be negative in the second and fourth quadrant. So I can pick those up with my pi over 6 in that quadrant. So I think it's 5 pi over 6. And then hopefully we remember this, but tangent is has a period of pi. So every pi, it will repeat. So just by adding pi, we would pick up the same value or the value we're looking for in the fourth quadrant. And you could check it, right? You'll get 5 pi over 6 plus 6 pi over 6, which is 11 pi over 6. So anyways, this is our solution, but this is for 3 theta. 3 theta is equal to that. So just solve for theta, and we'll say theta is equal to 5 pi over 18 plus pi over 3 times k. Let me double check our answer, and we're looking good. Just kind of racing through this. All right, so man, a minute a problem, that'd be amazing, but that's not going to happen. All right, so 3x plus pi is equal to negative rad 2 over 2. So this is the same problem as kind of the previous ones. We really want to say at what angle, and this is our angle, at what angle is the sine value negative rad 2 over 2? Well, this is where it's one of our pi's over 4s as our reference angle, but where sine is negative, sine is the y value, which is negative in the third and fourth quadrant. So we want to look at where 3x plus pi is equal to 5 pi over 4 for the third quadrant. So 5 pi over 4 plus 2 pi k. And then our other one is 3x plus pi is equal to 7 pi over 4 in the fourth quadrant plus 2 pi k. All right, and then I'm just going to solve. So I'll subtract off pi, so I'll get 3x is equal to, when I subtract pi from 5 pi over 4, well, then I'd have 5 pi over 4 minus 4 pi over 4. So let's just be pi over 4 plus 2 pi k. And then eventually I divide by 3. I get x is equal to pi over 12 plus 2 pi over 3 times k. Double checking that. Yep. And then on this guy, same thing, I'm going to subtract from by pi. Maybe I'll like be more explicit about this. 7 pi over 4 minus pi plus 2 pi k. When I subtract pi, it's the same thing as subtracting 4 pi over 4 when I make the same denominator. So that turns into 3 pi over 4 plus 2 pi k. And this is equal to 3x. I'll divide by 3, and I get pi over 4 plus 2 pi over 3k. That's not bad. Number 4. Let me double check that answer. Let's get number 4. Number 4 is 4 cosine squared x minus 4 cosine of x plus 1. I feel like this is like the most basic type of solving trigonometric equations. Like I feel like this is the most common type. So anyways, I'm just going to factor. It's equal to 0. Factors of 4. I think this is going to work as 2 cosine x, 2 cosine of x. As I said many times, I don't really have like a technique for factoring. I just kind of guess and check, So I guessed. Let's just confirm. So that is going to be 4 cosine squared, obviously the first term. When I go here, this will be a negative 2 cosine x. This will give me another negative 2 cosine x, which will give me a negative 4 cosine x. And then finally, negative 1 times negative 1 is a positive 1. Obviously, these are the same factors, so I'm just going to write it as 1. So this is 2 cosine x minus 1 is equal to 0. And I get cosine x is equal to 1/2. That's going to happen when x is equal to pi over 3, I hope, plus 2 pi k. And x is equal to, now cosine's positive in the first and fourth quadrant, so we need the pi over 3 in the fourth quadrant. And I believe that's 5 pi over 3 plus 2 pi k. Double checking my answer, make sure I did this correctly. I'm looking good. All right, on to 5. Let me scroll up real quick. 5. Well, this looks exactly like 4. Let's see, sine squared x minus 3 sine of x minus 4 equals 0. We're going to factor this sine of x, again, I guess, and then I check. Let's see, so negative 4 and a plus 1 equals 0. And I'll double check sine squared. That will be a positive sine x, and that's a minus 4 sine of x. That's a sine squared. And then a minus 4, it does work out. When I solve this, I'll get sine of x is equal to 4. That's never going to happen. And then I'll get sine of x is equal to negative 1. That will happen, just not as frequently. This is x is equal to 3 pi over 2 plus 2 pi k. Looks correct. On to 6. Just moving along. Let's see. 3 tangent cubed x is equal to tangent x. A real common technique, a real common mistake here is kids will like divide both sides by tangent, but you don't want to do that. You'll lose answers. You're gonna have to trust me on that. All right, so then I'm gonna say 3 tangent cubed x minus tangent x. That whole like set it equal to 0, and then I'm gonna factor. So I get tangent x is 3 times tangent squared x minus 1, and this is equal to 0. I'll set each factor equal to 0, so I got tangent x equals 0. And 3 tangent squared x minus 1 is equal to 0. Be careful with this one. This is going to produce 2 answers, and I'll show you real quick. This is going to be tangent squared x is equal to 1/3 when you solve for tangent squared x, and you'll get tangent x is equal to plus or minus 1 over the square root of 3. All right, so then let's get some answers. when is tangent x equal to 0? Remember, tangent is sine over cosine. So it's saying when the numerator is equal to 0. So when is sine equal to 0? Sine is equal to 0 at x is equal to 0. 0 plus 2 pi k. Actually, I'm going to do that the whole tangent period thing, and then I don't have to worry about it. Because sine is 0 at 0 and pi. So if I do 0 plus pi k, I'll be good to go. And then this has two answers again. So this is tangent x is equal to positive 1 over rad 3. And again, we had this conversation before. This is like sine is 1/2 and cosine is rad 3 over 2. And they're on the unit circle. So when is sine positive 1/2? That's going to be pi over 6. Plus, and again, you don't have to do the 2 pi k thing because tangent has a period of, I'm thinking. Tangent has a period of pi. So tangent's positive in the first and third quadrant. So if I do plus pi k, I will get that answer. And then I want to look at when tangent of x is equal to negative 1 over rad 3. So now we're talking about the second and fourth quadrant. So I'm going to say 5 pi over 6 plus pi k. And that is problem number 6. I want to double check the answer. Okay, 0 plus pi k, pi 6. Yep. On to the next, on to 7. I got cosine 2x is equal to 5 sine of x minus 2. I'm going to use double angle for cosine. So I'll say cosine squared x minus sine squared x is equal to 5 sine of x minus 2. I'm going to convert everything to sine, and hopefully that makes sense because we have this term here. And it'd be difficult to get everything into cosine. You want to deal with that, you'll have to deal with square roots. So I think it's a lot easier to get everything into sine. We know that cosine squared is equal to 1 minus sine squared of x minus sine squared of x is equal to 5 sine of x minus 2. This will turn out to be, when you drop the parentheses, this will turn into 1 minus 2 sine squared of x is equal to 5 sine of x minus 2. I'm going to move everything to the right because I want the leading coefficient to be positive for whatever reason. 0 is equal to 2 sine squared of x plus 5 sine of x. And then I'm going to move this guy over, and that's going to be a minus 3 if I did that correctly. And then I'm just going to factor, like I got a 2 sine of x here. I know my other, okay, so this is sine of x, and I know my other terms here have to be factors of 3. So there's only so many options, again, guessing and checking, but I think you get so good at guessing and checking, you can kind of like, okay, I need to make, if I want to make a 5, one way of making 5 is you make a 6, a positive 6, and you subtract off 1. So I believe this has to be a positive 3, so that when I go this to there, I'll get my positive 6 sine of x. And this has to be a minus 1. So I get my minus sine of x, and that will give me a positive 5 sine of x. I hope that made sense. All right, and then solve each one. I'll get sine of x is equal to 1/2, and sine of x is equal to negative 3. This will never happen nowhere on the planet. This will happen. This will 100% will happen. When will this happen? This will happen at pi over 6 plus 2 pi k for the first quadrant. And the second quadrant, because sine's positive in the second quadrant, is 5 pi over 6 plus 2 pi k. Oh, loving those radians, I think. Double check my answer, number 7, pi over 6 plus 2 pi k, 5 pi over 6. Yep, perfect. On to 8. It's like, assuming the answers are right. All right, so 2 sine squared x minus cosine of x is equal to 1. I don't know why this one seems easy. Move everything into cosine. You have to. So 2 times 1 minus cosine squared x minus cosine of x is equal to 1. Distribute. So 2 minus 2 cosine squared x. I feel like I'm doing something wrong. We'll see though. Minus cosine of x is equal to 1. Similar to the last problem, I'm going to move everything to the right. So I get 0 is equal to 2 cosine squared x plus cosine x minus 1. And then I'm going to factor and solve. I got 2 cosine of x, cosine of x. I need a positive 2, so this will give me a positive 2 and a minus 1. And then I have two answers here. Cosine of x is equal to 1/2, and cosine of x is equal to -1. What is cosine x equal to 1/2? That's going to be x is equal to pi over 3 in the first quadrant. And x is equal to the fourth quadrant, 5 pi over 3. Cosine's positive in the first and fourth quadrant. Cosine's negative in the second and third quadrant. Whoa. When is cosine -1? Cosine -1 at pi. When's the next time it's going to be? You add 2 pi. So this is going to be 2 pi k. Ooh, that is problem number 8, I think. 8. Let's just double check the answer. We got a pi over 3. We got a 5 pi over 3. And we got a pi plus. Yep, perfect. All right, on to 9. Okay, so I think the first page was pretty doable. There's a couple tricky tangent ones, but the most part pretty doable. And then I think the last page becomes like not doable, but we'll see. I got tangent x minus 3 cotangent x equals 0. I'm going to rewrite this in terms of tangent. I guess you can go to sines and cosines, but I don't know. I think it might be easier. All right, and then I'm going to multiply both sides by tangent. And the reason I'm doing that is I'm going to get rid of fractions. Tangent x times tangent x. And when I distribute on the left-hand side, I'll get tangent squared x minus 3. Hopefully that makes sense. When I distribute to this, the tangents will cancel out. And then 0 times tangent is 0. And so then I say tangent squared x is equal to 3. So tangent of x is equal to plus or minus the square root of 3. Let's talk about the positive version of it. So this is the square root of 3. This is going to happen, remember tangent's a ratio of sine over cosine. So this is equivalent. So we want where the sine is rad 3 over 2. Sine is rad 3 over 2 at x is equal to pi over 3 plus pi k. This will pick up the first and third quadrant. So when I add pi to it, I will get 4 pi over 3. That'll be the third quadrant. Again, the period of tangent is pi. You don't have to do 2 pi k on the tangent values, and you'll get them. On to the negative. So tangent of x is equal to negative rad 3. It's going to be for the same reference angle of pi over 3, but now it's the negative. So talk about the second and fourth quadrant. The pi over 3 in the second quadrant is 2 pi over 3. And if I do the pi k thing, it'll pick up the value in the fourth quadrant since, again, maybe I'll draw a picture here. There are 60 degrees. There are 60 degrees. It is pi apart. But we should know that because the period of tangent is pi. All right. Double checking answers just in case. This is number 9. Looks good. On to 10. Here we go. Here's 10. 10 is cosine x minus sine of x is equal to 1. Okay, so I did have students like look at this and know the answers. And that's fine. And that doesn't bother me. But we got to make sure we get all the answers. So I am going to do the trick of like squaring both sides because we like trigonometric functions being squared because then we can convert to one of the values. So I'm going to try that. I'm just going to square both sides. Square both sides, square both sides. But understand, by squaring, we're picking up extraneous solutions or potentially picking up extraneous. We're not guaranteed, but there's a great chance that we may pick up extraneous solutions. Remember, if like -1 was equal to 1, if we square both sides, then you just made a true statement. Anyways, when I square this, I'll get cosine squared x minus 2 cosine x times sine of x plus sine squared of x is equal to 1. Again, I like FOIL it out. First times first, outside times outside, inside times inside. And if you notice real quick, and I don't get to observe too hard, and it's one of our really, really big identities, cosine squared plus sine squared is equal to 1. So I get 1 minus 2 cosine of x times sine of x, and this is equal to 1. These ones do cancel out, which is very, very convenient. So then I get negative 2 cosine of x times sine of x is equal to 0. And then once I have a product equal to 0, I can set each factor equal to 0. Cosine x equals 0, and sine of x is equal to 0. So basically, with cosine x equal to 0 and sine of x equal to 0, we got all the axes values. And you gotta check your answer. And I know it's like a pain in the butt, but remember my original problem, maybe different color. My original problem is cosine x minus sine of x is equal to 1. And I need to go around and check. So my first potential, so I guess these are like the potential values. I'm saying it's 0, pi over 2, pi, and 3 pi over 2. And then I'm going to check all of them. So I plug 0 in here. I get cosine of 0. Cosine 0 is 1. Sine of 0 is 0. So 1 minus 0 is 1. This works. So one of my answers here, that's good. I'll just keep on going. And then pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1. 0 minus 1 is actually negative 1. This does not work. Now I plug pi in there. Cosine of pi is negative 1. Sine of pi is 0. Again, this is another negative 1. But remember, when we squared out the sides, I mean, we're making them equal. Like when you square negative 1, it is 1. So this does not work. Let's try 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1, but you're subtracting a negative 1, so that turns into 1. So these two both work. Now, how do we write that? Well, that's going to be 0 plus, let's see, these, no, they're not pi apart. One's here and one's here. That's not pi apart. And I know you're like, oh, it's 3 pi over 2 apart, but that's true for the first one. But when we try to get to this one, that's not 3 pi over 2 apart. So you have to write both. So this is 0 plus 2 pi k and 3 pi over 2 plus 2 pi k as our answers. That is correct. All right, 11. All right, those backside pages, very challenging. Tangent x plus 1 is equal to secant x. I'm going to square both sides as we did. So I'm going to say tangent x plus 1 quantity squared is equal to secant squared x. I get tangent squared x plus 2 tangent of x plus 1 is equal to secant squared x. And then now I got to do some side work. And the reason I have to do side work is I know there's a relationship between tangent and secant, but I always forget. So I start with the Pythagorean theorem. Cosine squared theta plus sine squared theta is equal to 1. I guess that's the Pythagorean identity, like the most basic one. And then I go, I know I have a relationship between tangent and secant. And so I got like, how do I make a tangent here? Well, if I already have a sine, if I divide everything by cosine squared, I will get a relationship between tangent and secant. So I'm dividing by cosine squared. This will turn into 1 plus tangent squared theta is equal to secant squared theta. Wow. And if you notice real quick, I have a tangent squared theta plus 1. And as we said, tangent squared theta plus 1 is secant squared theta. So I got secant squared x plus 2 tangent of x is equal to secant squared x. These will cancel out. I get 2 tangent of x is equal to 0. When is that equal to 0? That's going to be equal to 0 when sine is equal to 0 because tangent is sine over cosine. When is sine equal to 0? Sine is equal to 0 at 0, at pi, and so on, and 2 pi. So I'm going to say our answer is 0 plus pi k. Boom. Double checking the answer. That is not correct. Why not? Hold on, number 11. Okay, let me think. Give me 1 second. Give me 1 second. Oh, I forgot. We squared both sides. Ugh. See, I forgot. We gotta check. We gotta check for extraneous solutions. Yeah, okay, to be honest, as a good math student, and I'm not saying I'm a good math student. To be a good math student, you gotta check your answers. You know, when you're solving equations, you should always check, but especially with extraneous solutions. And I know you're thinking like, oh, how can I check all these answers on a test? It's a good question. Good question. Okay, let's put in 0. Okay, so let's first try 0. All right, so I'm plugging 0 into tangent x plus 1 is equal to secant x. Okay, plug 0 in there. Tangent of 0 is 0. Secant of 0 is 1. That works. That works. Okay, perfect. So we're good. Okay, what about this guy? All right, pi. Tangent of pi is going to be 0 again. So you get 0 plus 1. Oh, I see why. Secant of pi is actually negative 1 because it's 1 over cosine of pi. Cosine of pi is negative 1. So this doesn't work. Okay. So therefore, it has to be 0 plus 2 pi k, which is just 2 pi k. And that was okay. I'm going to say I missed 1 so far. All right, 12. Dad, I know we want to jump into this and use like double angle formulas because that's what we did before. But like, if you do this more intuitively, like it's a lot easier, And you have to think of this, and you're gonna have to like trust me on this. Like at certain places on the unit circle, this is going to be a true statement. Like they're going to be opposite values. Specifically, we want to look at like, how do I say this? Okay, I'm gonna look at a different problem for now. Let's just say I had sine of theta, and we had equal to cosine of theta. Now we could do that like square both sides and like play around with that, but it's not fun. Like you don't necessarily have to do that. I'm going to do this intuitively and say like, when are these two things equal? On the unit circle, these things are equal at pi over 4, and they're equal at 5 pi over 4. And the reason why is sine and cosine at pi over 4 are both rad 2 over 2. And at 5 pi over 4, they're both negative rad 2 over 2. Okay, so let's go back to that, like knowing that, let's go back to that one problem. And it was like sine of 2x. The problem we're starting on, sine of 2x minus cosine of 2x. Now, when are they opposite? They're going to be opposite. Same thing, pi over 4. They're both going to be a pi over 4, but we want them opposite in value. So that's going to happen at 3 pi over 4. And I'll show you, watch, like I'll do like, I'm going to do this like 2x is equal to 3 pi over 4. Now, sine of 3 pi over 4 is positive rad 2 over 2. Cosine of 3 pi over 4 is negative rad 2 over 2. And so those are exactly opposite. And this is going to happen, let's see, plus 2 pi k. And this is also going to happen at 2x is equal to, they would also be opposite in the fourth quadrant, which is 7 pi over 4 plus 2 pi k. And then we just solve for x. X is equal to 7 pi over 8 plus pi k. And x is equal to 3 pi over 8 plus pi k. I'm going to check my answer here. This is problem number 12. Okay, they got 3 pi over 8 plus pi k. Why? Oh, I understand. Okay, so if you notice, 3 pi over 4 is here, and 7 pi over 4 is here, and they differ by pi. So you can just add pi together. So this statement, I guess this statement right here, is equivalent to saying 2x is equal to 3 pi over 4 plus pi k. And then divide both sides by 2x is equal to 3 pi over 8 plus pi over 2k. Okay, I'll take it. On to 13. 13 is yelling. Let's see. I'm just going to start it. 2 sine of 2x plus 2 sine of x is equal to 2 cosine of x plus 1. I'm going to use the double angle for sine, and at the same time, I move everything to the left. So I got 2 sine of x times, oops, I lied. The double angle for sine is 2 sine of x times cosine of x, but there's already a 2 out there. So this is going to be a 4 sine of x times cosine of x plus 2 sine of x minus 2 cosine of x minus 1, I believe, if I did that right. All right. There's 4 terms, and you have to be careful, so I'm going to make this adding the opposite. There's 4 terms. When we have 4 terms, we tend to factor by grouping. So here's factor by grouping. Pull out the greatest common factor. For this term, for this grouping, the greatest common factor is 2 sine. So I'll put 2 sine of x. What's left in the first term? It'll be 2 cosine of x plus 1. All right, and on this one, we can factor out -1. And what's going to be out left? 2 cosine of x plus 1. And I feel like we're all pretty good at like factor by grouping. At first, at the beginning of the year, people are like, how does this work? But we have 2 terms. Like, see, this is one term, and this is another term. And the question is, what's the greatest common factor between those terms? Well, we have 2. We have 2 of those bad boys, so we can factor each one of those out. So we'll have 2 cosine of x plus 1. In the first term, I have 2 sine of x. And in the second term, I have -1. Again, if I pull out the 2 cosine of x, which is there, 2 cosine of x plus 1. In the first term, I have 2 sine of x left. In the second term, when I pull that out, I'll have -1 is equal to 0. And then I solve. So I'll get cosine of x is equal to -1/2. And I'll get sine of x is equal to 1/2. And I'll solve this bad boy. When is this true? This is true at pi over 3, I believe. Pi over 3 plus 2 pi k. And x is equal to, let's see, cosine is, oops, I lied. It should be 2 pi over 3. It's negative 2 pi over 3. And 4 pi over 3 plus 2 pi k. And then what about sine? We'll get x is equal to, when is sine 1/2? That's going to be my pi over 6 in the first quadrant plus 2 pi k. And in the second quadrant, it's 5 pi over 6. Sine's positive in the first and second quadrant. And there it is. Let's triple check. Pi over 6 plus 2 pi k. 5 pi over 6 plus 2 pi k. 2 pi over 3 plus 2 pi k. And 4 pi over 3 plus 2 pi k. We're good. On to 14, the last one. That was a long video, dude. Really long. Sine of 3x times cosine of x minus cosine of 3x times sine of x equals 1. Okay, like, square both sides, do sub, you're going to get yourself in trouble. You really are. This is really a step back and look at it. I'm going to write a formula here. Here's a formula. Angle difference formula. This is sine of A times cosine of B minus cosine of A times sine of B. Unfortunately, And we're going to use this. We're going to use angle difference formula. So I'm going to write this down. Like this is my A, and this is my B. That's my A, and that's my B. So therefore, that first expression can be rewritten as sine of 3x minus x. 4 facts. This is equivalent to sine of 2x is equal to 1. For what values of 2x is sine equal to 1? Sine will be equal to 1 at pi over 2 plus 2 pi k. What's x equal to? X is equal to pi over 4 plus pi k as my answer. There it is. It's okay. I missed one. It was 11, I think. Yeah. Let's have to do the history. I mean, like, I said as good math students, we check our work. Like, we solve and we check our work. We solve and we check our work. But one, you feel like you're going to be limited on time. And two, we just, I don't know, like, it just stops happening. But in theory, we should always check our work. We should always check our work. Even like for this problem, like check your work. Like make sure it works. Like we're saying, x is equal to pi over 4, right? So you're like, that'd be fine if it didn't work. All right, so then you get like sine of 3 pi over 4 times cosine of pi over 4 minus cosine of 3 pi over 4 times sine of 3 pi over 4. All right, and then you do sine of 3 pi over 4. Well, that's in the second quadrant, so that's rad 2 over 2 times cosine of pi over 4. Well, that's just rad 2 over 2 minus cosine of 3 pi over 4. I believe that's going to be a negative rad 2 over 2. Times sine of pi over 4. This is a rad 2 over 2. Delete. Let's check our work here. So this is going to be, when I multiply this together, this is going to be rad 4 on top and 4 on the bottom. And when I multiply these together, same thing, but now it's going to be plus rad 4 over 4. And this will be 2 over 4 plus 2 over 4, which indeed is 1. Yeah, it worked. It worked. Yeah. Thank you guys. Long video. I mean, hopefully your teacher had you start this work at home, because it's not reasonable to have 38 minutes homework video. And I kind of rushed it, so it should have probably been like 45 minutes or 50.